Hello and welcome to Math with Mrs. Becker. Today we are looking at Pre-Calculus, Chapter 2, Section 1. We will be solving equations using the graphing utility Desmos.com. So you want to make sure that you have access to Desmos.com, whether it be on your phone, on a computer, or on a tablet. When you first go into Desmos.com, there will be an option to log in or sign up. You do not have to log in or sign up. Just go ahead and click the option that says Get Started or Graphing Calculator, and you will have this screen. It is a free app. You do not have to download anything. Just go ahead, Desmos.com, and you'll be all set. Let's start today's notes. A solution of an equation is a number that, when you substitute it in for the variable, it produces a true statement. So when you say something like x equals 1 or x equals 2, what that means is if you go back to the original equation and you replace x with 1 or 2 or whatever that solution was, your result will be a true statement, meaning you'll end up with something like 5 equals 5 or 10 equals 10. Your variable has a value that makes the equation true when you fill it back in. Okay, two equations are said to be equivalent to one another if they have the same solutions. That means that when you go ahead and solve them and you look back at the solutions, if two equations are equivalent, their solutions are going to be exactly the same. Now, when we looked at 2.2, because remember we went in reverse order, in 2.2 we used algebra techniques to solve linear and quadratic equations. So we did things like the quadratic formula. We factored. We solved equations by doing opposite operations. We completed the square. So we did those skills that we learned in Algebra 2, and what we were doing was solving equations. However, we're going to end up with some crazy equations. So if you look down at our examples, we have like powers of 5 and powers of 4 and absolute values. And here's the deal, when you get into some of these more complex equations, the quadratic formula isn't an option. Factoring doesn't work. Completing the square is not going to work. So when we get to a point where all of those algebra skills really don't help us, that's when we need to go ahead and use graphing to approximate our solutions. And that's what we're going to do today. We will look at two different ways that you can do this, okay? One way is called the intersection method. The other way is called the x-intercept method. And both options, what they're doing is just helping us solve equations, okay? If I'm looking at the intersection method, what you need to remember is that if you have two functions that intersect, what you're looking for is the exact location where they meet or where they cross. So that's what the first method is really looking at. You will graph because they want to know when these two equations are equal, okay? What value could I put in for x that will make the two sides have the exact same value? It will make it have a true statement. In order to do that, you graph both equations in the same viewing screen. So you have to go ahead and first put in the absolute value of x squared minus 4x minus 3. Then on a separate line, x cubed plus 4x minus 6. So let's go ahead and do that on Desmos.com, okay? The first side of the equation, to get absolute value, remember that's right above ABC. So it's the absolute value of x squared minus 4x minus 3. To close your absolute value, you have to make sure you go ahead and tap that again. So I'm going to start off, I will sketch what I have here. We will go ahead and sketch our graphs. So this kind of looks like a really funky W. So there is our first equation. Now on the same viewing screen, so remember I can go ahead and hit those two arrows, tap right underneath the first equation, and I will put in the second equation. X to the power of 3 plus x minus 6. Now again, if I do not want to see the equations, I want to be able to focus more on the graph, you can hit the down arrow. I see an intersection point, but again, what I need to do first is sketch it. So here is your first point. You graphed both equations on the same screen. So again, you'll go ahead and sketch it. You're looking for intersecting points. So the cool thing is with Desmos, you can go ahead, zoom in, zoom out. So if I zoom in, here's the point where they touch. So this has one solution, okay? That one solution is right here, the ordered pair. And remember, if I want to see an ordered pair in Desmos, you just simply tap on the screen. So there is my ordered pair, 2.207 and 6.957. Okay, what you're doing is your solution is actually the x-coordinate. So I graphed both on the same screen. I identified that there would be one solution because there's one intersecting point. Here's where the intersecting point is. Identify the x-coordinate. The x-coordinate is the actual solution. So 2.207. This is the solution. And what that means is if I go to this side, and we will just for this one, if I go ahead and I put 2.207, the x value in this side, 2.207 to the power of 2 minus 4 times 2.207 minus 3. I end up with negative 6.957, okay, so approximate. It is inside of an absolute value, so when I put that in there, it's approximately positive 6.957. Okay, remember if I had a negative and if I take the absolute value of a negative, what you're saying is how far is this value away from 0 on a number line? Well, it is 6.957 units. The negative just means that you're going to the left. Okay, now to make sure that if I fill 2.207 into the other equation, you want to make sure you get the same answer. So let's go ahead and try it. 2.207, close it, to the power of 3 plus 2.207 minus 6. Now again, if I look at this, I get approximately 6.9569 would round up to the 7. So what happened is we graphed both on the same screen. We saw that they intersected at one point. We found the ordered pair. The x-coordinate is actually your solution because when you're solving something like this, what the question is really saying is what value can you fill in for x where the two sides would be equal to one another. Okay, so when I put 2.207 on this side, I got approximately 6.957. When I put it into this side, I got approximately 6.957. So your solution is 2.207. Okay, let's go ahead and look at another one. Now, what I wanted you to realize is that sometimes the screen is not so nice. Okay, so here I zoomed in. If you want to go back to a normal screen where you can see all 4 quadrants, that's what that home key means. So if I hit the home key, it goes back and I can see quadrants 1, 2, 3, and 4. Now to delete those, I just go next to the equation, hit the X key. Let's do this again. If I have 6x to the power of 5 plus 80x to the power of 3 plus 45x squared plus 30. Okay, so right now I can see that this is going to be kind of hard to identify because I did see at one point there was a little curve, so I know it's there. I can't see it, so I will have to adjust my window. But first, let's go ahead and put the second one in here. So 45x to the power of 4 plus 86x. All right, so I see this, but it's kind of distorted. So in order to set your window, you go ahead and hit this. Now this is trial and error. You can try different numbers, and if you can't see the graph better, keep trying other ones. X-axis, well, I'm just going to keep that negative 10 to 10. This seems really, really stretched out, so I'm going to go like, well, let's go negative 50 to like positive 80. Because what that's going to do is let me see more going up and down. Okay, so at this point, I can see a little bit more of this picture. I can always zoom going side to side. Okay, so that's kind of cool. So if I go ahead and, again, I'm going to set this window a little bit better even. Let's say I go negative 10. You can always go ahead and change these. If I go negative 10 to positive 10, and I want to go, let's go negative, I don't know, 25. And I want to go all the way up to, let's say like 50. Just to see what happens. Okay, so this is a little bit easier to see. what I'm looking for are intersection points, okay? So if that's another cool thing. Look at this. Okay, so I get close. I can see, all right, these things intersect, but it's really hard to identify where. If you tap in the general area, Desmos assumes, okay, you tapped close to where they intersect. I'm going to show you where it intersects. That's what that gray point means. So if I go ahead and I tap that, I can see that there's one solution. It tells me it's negative 1.0922. Your y value at that solution is negative 29.887. What this means is if I put this x value into this side of the equation, I should get approximately negative 29.887. If I put negative 1.0922 into this side of the equation, I should get approximately negative 29.887. Okay, so your solution is x equals, your answer is the x value, because what you're doing is you're answering the question, what x value could I put into here where I would get a true statement? Okay, so again, hopefully that one made sense. Now here I can kind of look and it seems like maybe those two things will touch. Cool thing about Desmos, go ahead and zoom in. I can see that they're actually running parallel to one another. I do not see a spot where they intersect, so I do feel like we've got our one intersecting point. It is way down there, and again, it's kind of hard to identify, so go ahead and just tap on Desmos. It will give you the little gray point to get the order pair. You tap it again. Okay, one more with the intersection method. Now here I zoomed in and zoomed out like crazy. To go back to a normal screen, just hit home. To erase and get rid of those equations, I just hit the double arrow, hit the X, and hit the X. Last one, absolute value, x to the power of 3 plus 2, close it. So again, now here I'm going to zoom in a little bit. The last one I did not sketch, so this one I'm going to make sure I do. So I have a little point, and it kind of curves up a little bit. And again, these are sketches. Okay, so you don't have to have it exactly perfect. So that's what I got from the first side. Now I go ahead to type in the next one. You hit those little arrows, tap right underneath the first side of the equation. Now I can type in what was on the right side, 5 plus x minus x squared. Ooh, look at that, I have a parabola. So I'm gonna go ahead and sketch this. And again, it's just a sketch. Now this time, do you guys see where we have two intersecting points? It intersects there and it intersects there. So I have 2 points. This ordered pair, I have 1.359 and 4.512. The two graphs intersect there. In order to get the ordered pair on Desmos, remember you just go ahead and tap that point. This ordered pair is negative 1.488 and 1.297. So your actual solutions are the x values. So x equals negative 1.488 and x equals 1.359. Those are your two solutions. The reason you have two solutions is because when you look at the graph, those two equations intersect 2 times. Now, if you were going to check, let's just say that you didn't trust Desmos and you wanted to check and make sure. If you put 1.359 into the x's, both sides should equal approximately 4.512. If you put negative 1.488 into all of the x's, both sides should equal approximately 1.297. Now, the reason I'm saying approximately, let's just say that this ends up being an irrational number, meaning it fills up the whole calculator. What happens is Desmos is rounding. So anytime you're rounding, when you go back and check, it just has to be an approximate answer. Okay, let's look at our second method to do this. Now, a zero of a function, if they want you to find what is called a zero, that means that if you put a number into that function, the output or the solution ends up being a zero. So for example, if I have x cubed minus 8, 2 is a zero of that function, because if I fill a 2 in for x, I end up with a 0, okay? Zeros of functions, they also sometimes call them the roots. They also sometimes call them the solutions. And what it is, it's the location where when you graph something that's set equal to 0, your solutions are going to be where the y value is 0. So that's where it crosses the x-axis, okay? So this is just another method. So step 1, write the equation in the form where it equals 0. That means you have to take one side and move everything over so one side is equal to 0. So here, let's take x cubed, move it over here. Let's take plus 5, move it over here. So I would have x to the power of 5. This is x cubed. It's positive here, so I have to minus it here. This is a positive x squared. It remained positive because I left it on this side. Plus 5, go ahead and minus. So now it's set equal to 0. So that is step 1. If you are using the x-intercept method, you have to have it set equal to 0 first. Now you graph it using a graphing utility. So here's Desmos. Go ahead, I'm going to cancel out the last two, hit home to reset my window. I have x to the power of 5 minus x to the power of 3 plus x to the power of 2 minus 5. Now here is your graph. So now we'll sketch it. So I went ahead and I have a graph that looks like this. What we're looking for is where this graph crosses the x-axis. That's why it's called an x-intercept. Where does the graph cross the x? There is one spot right here. That is your one solution. So at this point, the y is going to be a 0. Your x value, that is the answer. So x equals 1.424. That is your solution. If I put 1.424 in this side of the equation, and I put 1.424 in this side, I would end up with the exact same value. So it's just a second way where you can find the solution. Again, if I was doing the intercept method, I would put this into Desmos, graph it. Put this into Desmos, graph it. Look to see where they intersect. Where they intersect the x value is the answer. The second way to do this is what we just did. Take everything from one side of an equation, move it to the other so it's equal to 0. Then your solutions, your x values, that is going to be wherever your graph crosses the x-axis. Okay, so you're doing the exact same thing. You're solving the equation. You're doing that using graphing. Just one way, you graph them separate and look for intercepts. The other way, you set it equal to 0 and see where it crosses the x-axis. Let's look at one more, okay? If I want to get everything over to one side so it's equal to 0. And again, I'm just going in that standard form. The highest exponent is a 5. It's positive here, so I'd have to minus x to the power of 5. I have negative x to the power of 4, positive 2x squared. Now, these did not change signs because they stayed on the same side of the equation. This is a plus 4, so I minus it to the other side. It's equal to 0. That is step 1 for the x-intercept method. Now I go ahead into Desmos, get rid of that. I have negative x to the power of 5 minus x to the power of 4 plus 2x squared minus 4. So here is my graph. Go ahead and sketch it. I have a little funky graph just like that. Remember, a sketch doesn't have to be exact. You just want to make sure that I can see what your screen looked like. When you're doing the x-intercept method, what you're looking for is where does your graph cross the x-axis? There is one location. So at that one location, whatever the x value is, that is your solution. So here, our solution, x equals negative 1.277. If you filled that value into this side of the equation and into that side of the equation, the two sides would equal. Okay, so solve by graphing. I did pick 10 questions out for you to do as your assignment because Desmos sometimes takes a little bit of time resetting your windows and whatnot. Tomorrow is a work day, okay? So today is just notes. Tomorrow during class, you will do 2 through 10, the evens, 22 to 28, the evens, and then number 32. You can find those questions in your textbook on page 87. And again, it's 10 questions where you will be solving equations by graphing. Hope you had a great day. I'll talk to you soon.